The final step of friction loss calculation is to apply the Bernoulli's law. So the law of energy conservation at any fluid system, the pressure head in one point plus the velocity head at that point, 2z, plus the elevation head at that point, plus if there is any pump that adds some energy at that point, and then minus the motor head that is taken by the system, and minus the loss in the system, and whatever left that will be available at point 2 in terms of pressure energy, velocity energy, and elevation energy. So in this case, in this problem, let's assume that we set the ground like our regular ground at point 1. So this is our ground, for example. If this is our ground, then G1 would be 0 and G2 would be 80. So let's go back and have everything plugged in that formula. So here we have already calculated this pressure head. Now you could either use this pressure head or pump head. Either way is fine. It could say pump head or this one. So don't just add 2 because you got only 1. So this must plus velocity head 0, elevation 0, no motor, and then loss we have calculated. I think it was 1.16 or something. Let me pause and get this number. Yes, so that was calculated 1.16 and then equal to the pressure head at point 2. That's what you have to find out. Velocity was calculated 2.27 feet per second, and then the 2 times the gravity is 32.2 feet per second is square, and then the elevation was 80 foot from that ground. Now I can solve for P2 by gamma, which I found 149.53 feet of water. Now we can convert this to then P2 would be simply multiply this by gamma of water, which is 62.4 pound per feet cube. So then this will be in 9331 pound per feet is square. Now normally pressure is in psi, so I'm going to cancel that feet is square. I know 1 feet is 12 inches, so whole square that. So then this pressure is calculated as 64.8 psi. So that is the available pressure at point 2, considering all friction losses and accounting everything.